Hey, math enthusiasts. I'm here to help you out with the practice for the 8.2 section about circles and inscribed angles. So for this first example, it looks like I'm given this inscribed angle. It's 20 degrees, and it opens up to this arc. Obviously, I'm looking for this inscribed angle, and it opens up to the same arc. Well, as I know, my inscribed angle is half the measure of my arc. So I know that this arc is going to be 40, which means that this inscribed angle is also going to be 20, because it's half the measure of the arc. For this next example, similar situation, I'm given this inscribed angle, it's 20 degrees, so therefore I know that this arc up here is going to be 40 degrees. But the difference is I'm looking for this arc measure, this x. Well, I noticed that this is a diameter, which means that this is going to be a semicircle, 180 degrees. Well, we already have the 40 up top, so if I take that out, I'm left with 140 for x, for this arc measure right here. For this next problem, I'm looking for this inscribed angle x. All right, so once again, focus on the intercepted arc that it opens up to. Well, if this is a diameter, then this intercepted arc must be a semicircle, which means that this angle up here is actually going to be a right angle. So x is going to equal 90, and that was actually one of the theorems from my notes in this section. For this next example, the one piece of information they give me is this inscribed angle right here is 10 degrees. Now, I could find this arc if I want, but I don't really think that's going to help me get to x on the other side. So instead, what I'm going to focus on is the other piece of information they gave me is the fact that this chord and this chord, they're parallel, which tells me that this angle, this inscribed angle where the 10 is, and this angle down here, those two, they form the Z. They are alternate interior angles, which tells me right away that this angle is also going to be 10 degrees. Now, as I said, the arc that I'm worried about is this one. Well, that 10 degrees that I just marked, this is an inscribed angle. It opens up to this intercepted arc, which is going to be double that measure. Next one's very straightforward. We have an inscribed angle here, 25 degrees. I'm looking for the intercepted arc. I know it's going to be double that measurement. So x is 50. This problem was a lot like the first one. We have an inscribed angle, 50 degrees. It opens up to this arc. Now, I can find that arc measure if I want. I know it's going to be 100 degrees, double the inscribed angle measure. But what they want is this angle over here, which opens up to the same arc, 100, which tells me that V must also be 50. For number 7, the first thing I'm given, 60 degrees for this inscribed angle, which means that this arc is going to be double that measure, 120 degrees. Next thing I notice is that they give me a diameter right here. All right, well, if that's a diameter, that means that this arc around here is going to be a semicircle, 180 degrees. So all I really have to do is take out that 120, which is going to leave me with 60. So H is going to be 60. Next problem, we have two variables to worry about, x and y. So let's focus on x first. The inscribed angle across from it is 45 degrees. I'm looking for the intercepted arc. I know it's going to be double that 45. So x is going to be 90. Next one I'm looking for is y. Well, same deal. Y is an inscribed angle, but now you actually have the arc measure. So what I'm going to have to do is take 76 and split it in half, which gives me 38. Next problem, we're given 70 degrees. I'm looking for E, but we got to work our way over there. So using that 70, I can find this inscribed angle, which is going to be half of 70, which gives me 35. Now, the other thing I notice is that these two chords are parallel. So similar to the previous problem, these angles in here that form the Z, they are alternate interior. All right, which tells me that this angle down here where E is also must be 35.